lesson, we're going to look at inverse relations and functions. And we're going to learn characteristics about inverse relations and functions, including domain and range. So this one will be a big one, especially when it comes to inverse functions. If we know the original function and we know their domain and range, we should be able to know the inverse's function, domain and range as well. So yeah, have a look at that. Okay, find the inverse of the following functions. So what I'm going to do is give myself a line in the middle. Okay. The first thing we need to do to find the inverse of this is just swap x and y. Now, by swapping x and y, we're changing the equation completely, so we need to explain what we're doing. So I'm just going to go swap. Swap x and y. So we've got a situation there. So we've got x equals 3y minus 2. So notice that the x becomes y, the y becomes x. So I've written the same thing except two different ways. Okay? All right, let's keep going. So now I've got to make y the subject. Okay, so I've got 3y equals x plus 2. So I've moved this guy to the other side and turned things around. So I've got 3y by itself, but I've put him there. Okay, I'm almost there. So I've got, therefore, y equals x plus 2 over 3. Okay. Now I can say a therefore again, so I'm going to get my red pen. I'm going to go therefore inverse function of y equals 3x minus 2 is y equals x plus 2 over 3. Okay? So the inverse function of that is this guy here. Okay? Now we actually have a notation for that so you can distinguish it. So the inverse function is going to be written like this. You go f inverse 1 of x equals x plus 2 over 3. Now that explains what we've written in red. Okay? As long as this is f of x. So we just need to write it that way. Okay, so the main thing that we take from this is if we want to find the inverse function, let's swap x and y. That's essentially what we're going to be doing, and the rest is algebra. They can get tricky, but it's only because the algebra is tricky, nothing else. Okay, so we're going to look at domain and range, and I'm just going to start like I do with many topics, and we're just going to go y equals x squared. So I'm going to draw it. Okay, so that's the y equals x squared of the function. Okay, so what's the domain? Domain of this one is x, so we're looking this way, aren't we? And it will just keep getting wider and wider and wider. So domain is all real values of x, okay? Now the range, remember with the range we're looking at y. Now there's nothing down here and it all starts here at 0, okay? So range is y is greater than or equal to 0. For real values. Okay, so that's the domain and range. Now, what is the domain and range of the inverse? Well, I'm going to do the inverse. I'm going to draw it. You can draw it in Desmos, but essentially the inverse, we're going to swap x and y. So instead of being y equals x squared, it'll be x equals y squared. All right, so x equals y squared, and it actually looks like this. All right, so it's actually not a function anymore, it's an inverse relation. Okay, so what would the domain of that one be? Well, it looks like if we're domain we're talking about x, is that it's going to be all these positive ones and nothing down here. Okay, so that means that the domain is x is greater than or equal to 0 for real values, And the range, well, the range is y. It looks like it'll just get wider and wider, so it's actually going to be all real values. All real values of y. So we can just say all real values, okay. Now, what do you notice? The domain has become the range, and the range has become the domain. So because inverse relations, essentially all we're doing is swapping the x value for the y value. What is happening is that the domain and range, because domain's got to do with x and range has got to do with y, are swapping also. So that's really, really important. So you can write yourself a note. Therefore, for inverse functions, domain and range also swap. Okay, let's keep going. There's one more thing. We can actually visually see it, and we see it along this line. That's a very poor. And this is the line y equals x. So I've just drawn it there, okay? So we can see it along the line y equals x, okay? Now, just imagine you were back in primary school and you had a piece of paper and you drew some paint there and then you folded it in half. You get the same thing. You get the same thing. Actually, I could probably do this. And it was like a butterfly sort of thing. I got copy. You get the same thing on the other side, except the other way around. Okay, so you get the same thing, but on the other side, just the other way around. All right, I'm getting too fancy here. Okay, I've actually got zoomed it for some reason, but it should be the same thing on the other side. Now that thing occurs on this line, the y equals x line, this one. All right. So if you look at it, if we put, say we use the same analogy with the paint, if I painted this bit here and I folded it along this line, you would end up with this situation there, okay? Now I'm going to take this highlighter off so you can see it, but you can see that if you fold over this line, you'll get exactly the same thing. Now, the y equals x squared, so I'm looking at this one, it's inverse along this line. Now, the exponential, so exponentials are really cool because they're inverse to the logs. And look at this. This is the normal exponential. Here's the log. And you can clearly see if you had folded it in along this line here, that it will give you the mirror image. Okay? So it's really important that we learn to recognize it algebraically. Okay? And if you actually pick a value, so see how this is x equals 1. Well, the inverse graph is y equals 1. Okay, so we're swapping x and y, and we can see that visually too. Anyway, that's the end of this lesson. Peace out.